privilege and honor to welcome our guest speaker, Dr. S. Prabhu, who will be presenting the online training program on Introduction to Simulation Tools via today's webinar, especially focusing on magnet. Dr. Prabhu completed his undergraduate in electrical and electronics engineering from VLB Janakiyamal College of Engineering and Technology, Tamil Nadu. He completed his post-graduation with Power Electronics and Drives from Arunai Engineering College, India. He completed his doctorate in electrical engineering from Anna University, Chennai. He has published two e-books, 14 international journals, 16 international and national conferences. He is a lifetime member of IST. His research area is design and finite element analysis of electrical machines. Dr. Prabhu has 9 years of teaching experience and now currently working as assistant professor in the Department of Electrical and Electronics Engineering with Sri Vidyaniketan Engineering College, Tirupati, Andhra Pradesh, India. I welcome sir, and I over this session to Dr. Prabhu sir.
Thank you, sir.
Background sound also.
So, very good evening to everybody present here.
Background sound.
Good evening, sir.
So, in this section, we are going to discuss about two important software. So, according to the objective of our short-term training program, so in order to get knowledge on simulation packages over magnet as well as for the mechanical aspect, we are going for Ansys. So, coming to the simulation tool. So, in this section, I am going to discuss about magnet. So, what is the use of the magnet? So, the use of the magnet is to go with electromagnetic analysis for any electrical motor or generator or solenoid, anything. Wherever we give an input current or wherever we take an output current or voltage, we can go for an electromagnetic analysis, so we can prefer and which is a user-friendly package. But not only electrical analysis is needed for a electrical motor, but also mechanical aspect is also an essential to get a high performance with the machine. So coming to the mechanical analysis, we prefer Ansys, which is user friendly. So for the mechanical aspect, we are going for vibration as well as thermal analysis for a electrical machine. So in order to make this section somewhat better, interesting, I just take an application of electrical vehicle, so which is the trending one. So coming to electrical vehicle, so there is a motor. So in this electric vehicle, motor, what I did here is, I just taken an outer rotor. I'm not going for inner rotor, I just taken an outer rotor, whereas the stator is placed inside and the rotor is kept out. So that the outer part of the rotor is being now rotated. So which makes an advantages of to remove the transmission losses in the electric vehicle. Right? So that the performance of the machine will be, as well as electric vehicle also can be increased. Right? So now, how to model this machine? How to model this machine by using a magnet. Right? So now we are going. So before going to this modeling of a motor, we are going for the design requirement. We are going for a design requirement.
Prabhu, Prabhu, audio can be much better, not that much audible.
Okay, sir. Okay, sir.
Now it is perfect. Now it is perfect.
Okay. So before going to the modeling of a machine, first we have to consider the design requirements. We have to consider design requirements such as the output power, what are the speed, what is the required torque of a machine. So now we are going for modeling of a electrical motor, right? So for modeling of an electrical motor, we are going for a magnet packages, right? So this is the work page of a magnet packages. The link where we want to download the magnet packages, I just give in the Meet, Google Meet itself. I just paste in the chat box, right? So this is the workspace. So we have to arrange the workspace depend upon our requirement and needs. So before start our modeling of the workspace, we have to create our required environment. So environment here means, so what are the units that is required? What are the units? So here the standard unit here is millimeters. So what we prefer here is millimeters. So by keeping the millimeters and just apply it and then close it, right? Now, if you see at the bottom of this package, there is no toolbar available. So where we have to give the input, so that is not available here. So in order to get the input to the packages, so what we have to do here is just go to the tools and then give the keyboard input bar. Give the option as keyboard input bars. So now if you see at the bottom, we can able to find a toolbars, right? So now again I will show you to once again. Just go to the tools and then go to the keyboard input bar, so that a keyboard input bar will be available at the bottom, right? So with this keyboard input bar only, we are going to give the input to the packages such that the motor will be modeled in this package, right? So now, so first what I'm going to do here is, so I'm going to go to draw a inner part of the machine. So the inner part of the machine here is the shaft. The inner part as well as the center part of the machine here is the shaft of a motor. So coming to the shaft of a motor, it is in the form of circle. It is in the form of circle. So I just select the circle here. If you make an icon over the circle, so the circle icon is found at the top, which is found at the top, right? So there is add circle option is available. So in this case, it is having center comma radius. We can able to see the option with a circle is center comma radius. So now I just want to initialize the center. So center means nothing but it is 0. It is the origin point. So I just give 0 comma 0.
But ma'am used to tell like this, but she may work for
Just click the circle. Again I will just initialize 0 comma 0. So if we move the cursor, we can able to see that the origin starts from the 0. The circle starts from the 0, right? Then only it is meant that the initialization is done properly, right? Otherwise again we have to give 0 comma 0. Now, now I want to draw the shaft. So I just give the installation. After giving the installation, what I am going to do here is, here what we decided it is center comma radius. So I want to give the radius of the shaft. So now I am going to consider the radius of the shaft here is 10. That is 10 mm, right? Because I had mentioned the unit as mm, right? So if you see here, so this the circle is available. The circle is available at the workspace. We can able to see at the top. That is the radius up to 10 mm, right? Now, now what I want to do, I want to draw the back iron of the stator. Back iron of the stator. So again, if I want to draw anything, I want to make any correction in the diagram, I want to initialize the center point, that is the origin value, that is 0 comma 0. For every command, I want to give 0 comma 0. Right? So again, I just initialize 0 comma 0. Now, I just giving 0 comma 20 mm, right? So the diagram is now going out of the workspace. So what I'm going to do, I just go into the view all option, right? So this view all option is found in between the workspace, right? So I just click the view all option so that we can able to get the every part of the diagram inside the workspace, right? Now, now again I want to initialize the model 0 comma 0, right? So now again I can able to start from the origin, that is 0. So and then now what I'm going to do, I just go to
Okay, you
draw
can
the
also
stator poles.
word with
So for drawing the stator poles, I just want to make the length of the stator pole. So I just consider the length of the stator pole is as 30 mm. The length of the stator pole is as 30 mm.
Yesterday I called her twice.
Right? So now,
And she called me back at around maybe, yeah, almost quarter to 9.
now,
And at that point of time,
now
she
I want to
was
draw the
purchasing
stator pole.
rations
So
from
pole means that it will be having some line with some angle, right? So if you see the diagram, we can able to see that. So if this is the pole is having some line with some angle, right? So in order to make a line, I want to select the line here. So the line option is found at the top, which is below the boundary as well as the circuit option, right? So there is option meant as add line.
so many people are valuing
So I just click the option add line,
anytime anybody
and then again I want to give initialization to the model. So again 0, 0, right? Then only we can able to see that the line starts from 0, right? But I want to make the line with some angle. So what I want to do, here we can have an option as x comma y. The option here kept as x comma y. So I want to change this option, right? For changing this option, there is an option of toggle, right? Just click this one. So we got at the bottom, the toolbar is now changing into r comma theta, right? From x comma y, it is now changing into r comma theta, right? So that what I want to do, r means it is radius, theta means it is angle. So the radius what I given for the circle for the last one is 30, right? And then the angle what I was given, I want to give here is 11.
I became very afraid yesterday because
Right.
the
So this
journalist
is
from
the
where I was talking,
line what I
his mother
drawn here, right?
yesterday was positive.
Now, now a thread is now continuing here,
She
right?
has been taken now. She is
A thread is now
70 years old.
continuing here. Now I want to stop this
Very, very
thread.
afraid
So
yesterday.
how to stop this thread? Just
The moment I
give
typed
the
in,
escape button.
it was the
Just give
information
escape
network, the
option.
first
The thread
information
will be
network.
invisible. The thread will be invisible.
Immediately I
Suppose
made up my mind that
if
what
I
I
want
do.
to get this
So
thread
right now
once
I
again,
know that
if
I
I
need
want
to
to
be
get this
very
thread once again,
exactly
what I want
what
to
I
do
want
here
to
is
write an action.
just click the
Made that as my plan. When first the medicine
line
starts
option.
to
Just
get
click the
because
line option, which is found in
I
between the
there are
workspace, which is found in
any
between the
shop you go you have to stand in
workspace.
6
So
to 7
select construction
to wait.
lines. So
There
and
was
then
no
select the
pharma
line
shop
here,
for me to
right?
get my medicines.
And then go to the
Packed my
properties
medicines
by
and then I went,
clicking the right option.
purchased the ration
So we are having the endpoint here,
and back.
and copy this endpoint.
I took my path.
So after copying this endpoint, just paste at the toolbar. We are having a toolbar at the bottom. Just paste it at the toolbar. And then we have to check that
Sir, if student learn this package,
the option is in
there will
x
be
comma y.
possibility
It should not be in r comma theta. The option should be in x comma y,
from
right?
mechanical
And then select the line option,
magnetic
right?
package.
And then give enter.
It is not
So now we can be able to
included
get
in
the thread
any of the
once again,
package.
right? So suppose if you want to continue from this option, the thread is essential. Otherwise, this thread is not needed. Just I give escape once again. Now what I need here is, I want to draw,
So at least my thing should be ready.
I want to draw the same line
Overall of quality.
at the
Yes.
negative axis. So consider this one as a 4 quadrant. So this is first quadrant. So similarly, in the fourth quadrant, I want to make the line with the same angle as well as the same radius, right? So again, I am not going to give the values and all. So what I am going to do here is, I just going to give the mirror option. I want to go to give the mirror option. So just select the lines and then go to the draw option. So which is found at the top. Just go to the draw option and then go mirror edges. So this mirror edges is having the direction, right? In which side the mirror image has to be transferred, right? So there is option as 0, 1 as well as 1, 0, right? So I just select 0, 1. If you see here, what happens? The line is moving to the left hand side. But what I need the line to be transferred at the bottom. So I want to change the direction of mirror. So the direction of mirror is 1, 0. Again, if you see, the line is coming at the bottom. The line is coming at the bottom, but there is no line at the first quadrant. There is no line at the first quadrant. So what I want to do, I just select this one, go to the draw option, go to the mirror edges, and give the direction as 1, 0, and then click the apply the transformation to the copy of the selection. You have to enable this option. Then only what happens? The selected line will be there as it is, and then the line will be copied, right? So this is how we can able to transfer the lines, right? Now what I am going to do, I just go for a thread option here. Close this one. I got a thread option. Now what I am going to do here is, I want to draw a line which is perpendicular to, which is parallel to the x-axis, in the reverse direction. It is not in the forward direction. I want to draw a line in the reverse direction. So for that, what I am going to do, I just go for r comma theta. I just going for r comma theta such that the r is now going to be changed into del r comma theta. So r means it is the total radius. Del r means, so that point is now considered to be as the initialized point. Otherwise, what I want to do, I want to give 0, 0. So then what happens? The origin be the starting point. Now the starting point should be where I have the thread option. So this is the starting point. So to get this as a starting point, I want to keep del r comma theta, right? So now what I am going to do, I just go for a line option in the reverse direction. So previously I mentioned that I want to draw a line which is in the parallel to the x-axis. So parallel means there is no angle. Two parallel lines are traveling. That means there is no angle between them, so that the angle value is 0, right? And then del r. So del r means the distance from which I want to draw a line, right? So the distance I kept it as 15, and the angle be the 0. But I want to draw the line in the reverse direction. So I am keeping minus. See, I just obtained a line here, right? Now I selected this line. So the line, only this is essential. The essential line is only the radius from 20 to 30. The radius from 20 to 30 is essential, right? So the remaining things, so the remaining line is not needed. So I want to delete the remaining unwanted lines. So for that, what I am going to do, I just go for the segment option. So which is found at the top below the animate option. Below the animate, there is an option. A scissor tool is available. So that is the segment tool. So I just select the segment option. So which is unwanted, I just deleted this line, right? Now, only this line is available, right? Now again, I want to draw this line at the bottom side. So again, just go to the mirror option, and the option be 1, 0, and enable the apply the transformation to the copy of the selection, and then give apply, right? So this is how we want to draw the poles, right? Now what I want to do, I want to make a number of poles. I want to select number of poles. So now again go back to the PPT. We can able to see number of poles 1, 2, 3, 4, 5, 6. So totally I am having 6 stator poles. I am having 6 stator poles. Now I have drawn only 1 poles, right? Only 1 pole I have drawn till now. Again I want to draw remaining 5 poles. So the motor is in the form of circle. The motor is in the form of circle. So what I am going to do here is, I want 6 poles. So the angle of a circle is 360. So 360 divided by 6, it is 60 degree. 360 divided by 6 here is 60 degrees. So now I am going to select the line, right? So this line now has to be rotated. This line now has to be rotated. So just select all this line by pressing the control button. As in the word, as in the MS Word, the option remains same, right? Just press the control button and select whatever lines we want, more than one. And now go to the draw option and now go to the rotate edges, right? So coming to the rotate edges, there is a rotation angle. So rotation angle is nothing but 360 divided by 6. So it is 60 degrees. So number of
Prabhu, again audio has come down. Again audio has come down.
Okay.
Yeah, now it is perfect. Now it is perfect.
Okay. So now again, I want to make a number of copy record here is 6. I just give apply here so that I can able to obtain the number of copy as 6 rotor pole is now available. Now what I want to do here is, I want to delete what are the lines which is not needed for now, right? So for that I just select the outer radius and then select the segment tools, right? I just delete the lines which are not needed, right? Now similarly at the bottom also, right? So now at the bottom side also I want to delete which are the lines. So I am deleting this one. So again go to the scissor tool, that is a segment option. Select it. So now our stator model is ready, right? So this is the model, that is a wire diagram for the stator of a electric vehicle, right? Motor for an electric vehicle, right? So now what I am going to do, I just go for the coils here, because stator means it should have a windings. So I just make a slot. So for making the slot, what I am going to do here is just click the line option and then click here and just extend this line, right? So after doing this one, just go to the line selection and select the lines. So now the line which is coming inside the pole, it is not needed. So what I am going to do, I just want to delete this one. So I just cutted it. Again the line is not needed. So I just cutting this one. Now I want to mirror this one. Now I want to mirror this slot, right? So by pressing the control button, we can able to select more number of lines. I just mirroring this one, applying it, right? So now again I want to select the bottom slot as well as, and I want to rotate all those 260 degrees, right? So now I selected the slots for one pole. Now I am going to rotate this one. So I select the draw option and go to the rotate edges. Again, what is the option for pole? And the slot option also should be same. So 60 degree as the rotation angle as well as the number of copy is 6. And then apply it. So now the full wire model for the stator is now ready, right? So now what I want to do here is, I want to make this wire model into a solid model. That is, I want to make this wire model into a solid model. So for that I want to select the construction surface, and then select this area, right? And then I want to select the material. So for assigning a material, so what I want to do here is, I just go to the model, and then select make component in a line. I just select the option make component in a line. So after selecting this one, go to the model and then go to the option make component in a line. And then it is a stator, just rename it as a stator. And now I want to keep a material. I just go for a M19 material, and this distance is nothing but the stack length of a machine, right? The distance is nothing but the stack length of a machine. So what is the stack length, right? So now we will discuss that one. So I'm not giving the stack length, it is default value is 1. So now I am going to rotate this one. See here. So this is the width of the machine. So this is the width of the machine. Now what I am going to do, I just going to increase the stack length of the machine. So for that I want to assign the material. Again I am giving the stack length as 60 mm. Right? So why I am giving 60 mm means the outer diameter of the machine has to be divided by 2, right? So that be the stack length of the machine, right? That is the preferable one, right? So I just give 60 mm here and then give OK. Now I am going to show you the machine here, right? So if you rotate here, we can able to see the machine stack. This is the stack length of a machine here, right? Now again in this slot I want to make this slot to be filled with coppers, right? So select everything. So after selecting this one, what I want to do, again to assign any material, the procedure is same, right? Even it is a permanent magnet. So the procedure is same. Just go to the model and then make a component in line and then give copper. Otherwise just this option, there is lot of material will be available, right? So whatever we need, we can able to keep it, right? Again, the stack length of the copper and the stack length of the stator should be same, right? So our stator part is now ready. So now what I want to do, I want to draw the rotor. So for assigning a rotor, I want to make a air gap length. So considering air gap length as 0.3 mm, I just consider the air gap length as 0.3 mm, 0,0. So the outer right radius here is 30. Now after initializing 0,30.3, because I am giving the air gap length as 0.3, right? So I am going to take as 30.3. Now if we zoom here, we can able to see the distance between the stator as well as the air gap. We can able to see the difference in the air gap here. So this is the air gap distance, right? Now again I am just going to draw the rotor poles, right? So 0,40. I just go for the rotor poles. Again I want to draw the back end of the rotor. So again 0,0, again 0, right? So in this area I want to occupy with the rotor poles as well as the rotor back ions. So again rotor poles means I want to go for a line with some angle. I want to go for a line with some angle. So according to this purpose, what I am going to do, I just selecting the lines which is found at the top of the work page, that is below the boundary as well as below the circuits. Select the option that is r comma theta. I just select the option as r comma theta. Again, after selecting the line, I want to initialize the workspace as 0 comma 0. Again, I am giving as 0 comma 0 here and checking it. Okay, it starts from the origin. The thread starts from the origin. Now, the radius, right? The radius what I kept for the rotor pole is 40 and the angle. And I am keeping the angle as 12 because I kept the angle as 40. I just kept the angle as 40. Sorry, 1 minute. Now, there is two ways to assign the rotor poles. One is to select the angle up to this line. That is 30.3. Otherwise, we can go for the angle up to 40. Right? There is two ways. Now, again, select the lines 0 comma 0. Radius is 30.3, comma, the angle be 12. I given this one. Now there is availability of thread here, right? So with this thread, I want to continue the modeling. Right? So what I want to do, at the bottom there is option as r comma theta, and this r comma theta has to be changed into del r comma theta. So for that, I want to go for the toggle option. Again, the del r comma theta is now available. So this point is now considered as the starting point. Right? Now I want to draw a line. It is parallel to the x-axis. So parallel means there is no need of angle. The angle is 0. Again, now the line is now going to be drawn in the forward direction. So there is no need of giving negative here. Right? I want to draw a line in the forward direction. So just give enter here. I can able to see here lines which is available here. Right? Again, give escape button. Select the construction lines and delete this one. So that it will be clearly available for you. Right? So if I select this line, what happens? The entire thing is selected. Right? The entire thing is selected. Right? The unwanted lines. I want to delete this unwanted lines. So for what that, I just select the scissor tools and delete the unwanted lines and select the lines. Just go to the option as draw and go to the mirror edges and give 1 comma theta and give OK. Right? So that I had a line for both top as well as the bottom. Now I want to rotate these lines. Right? So now I had selected the lines. Right? So now I just go to the PPT here. Now I am going to count how many number of poles here. 1, 2, 3, 4, 5, 6, 7, 8. So I am having 8 stator poles. Right? So it is a circle motor. It is not a linear motor. It is a rotatory motor. So 360 divided by 8. So that gives our rotation angle. So the answer for 360 divided by 8 is 45. Here is 45. So the rotation angle here is 45. So after selecting the lines, I just go to the draw option and select the rotate edges. So after selecting the rotate edges, the rotation angle is needed, right? So in that space, I want to give the rotation angle as 45. Again, the number of copy also I want to change because I am giving the number of rotor pole as 8, right? And then I just apply it, right? So now I can able to see 8 rotor poles. Now, Now I just select the inner part of the rotor and I am going to delete what are the parts which is not needed now. So I selected the lines which is not needed. I am just going to delete this one. Similarly, there is a line which is joining the rotor poles as well as the back end of the rotor. I am just going to select the line also. So by pressing the control button, we can able to select more number of lines, right? Again, I just go into the segment edges. Now I have selected the lines which are not needed in the rotor and now deleted this one. Now again I want to assign a material for this because it is a wireframe model and now this wireframe model has to be converted into a solid model, that is a fabricated model. So for that what I want to do, I just want to do a assign the material. For assigning the material, again the procedure remains same as the stator. Just go to the model and make the option as make component in a line, right? Again, just go to the option here, it is given as name. So the name of the part here is rotor and the material what I am going to assign. So the material should be same as the stator as well as rotor. Again the stack length of the entire part of the machine should be same. So it is 60 mm. Now, so this is our model. Now I want to rotate and show to you. So this is the model. This is the model of our SRM for 6 by 8. Right? So this is the SRM model for 6 by 8. Right. Now what I am going to do, I just draw the model. Now I want to assign the coil. So which is phase A and which is phase B and which is phase C. Right? So for that what I am going to do, just go to the option, that is object, right? There is a option as object, material, coil, problem, field and view option. So in that case go to the option and then select the coils So there is component 4 is one coil size. Similarly component 5 is another coil size. So now I want to select 4 coil side as the one phase, right? 4 coil side as one phase. So now I have selected the 4 coil side as one phase. I have selected 4 coil side as one phase. Again I just go to the model option. We can able to see there is an option as make simple coil. Just go to the make simple coil and we can able to see the parameter, new parameter is coil hash 1. Right? What is this coil hash 1? Just select the coil hash 1. So the entire 4 coil side is now selected. So similarly I want to do for the remaining coil side. Right? So this is the cyan phase, that is cyan coil 1. Again go to the model and select the option as make simple coil and this is coil hash 2. Right? Now the remaining one. So now the remaining coil is selected and just go to the model and make a simple coil. So coil 1, coil 2 and coil 3 are fixed now, right? So this is not phase A, phase B and phase C. That is coil 1, coil 2 and coil 3. It is not phases, right? Now again zooming this one. Now I want to assign the direction of coil. So for assigning the direction of coil, so according to Fleming's left hand rule, so if this one is dot, that is for coil 3, I just going for coil 3. So for coil 3, if this is dot, the corresponding bottom also should be dot. But here it is cross here. So I just go to the coil option and select the entire thing. Now I want to change the direction of the current. So for that I just go for a right click option and give reverse coil direction, so that the dot is now up here. Previously it is cross, now it is dot. Similarly, this one is also now converted into cross, right? So the corresponding two sides should be dot, and the opposite two sides should be cross, right? So that is according to Fleming's left hand rule. Now, again assign a number of turns. So I just rename this one, that is pressing F2 button. Pressing F2, that is renaming. I just give 100 turns per phase. 100 turns per phase. Now, going for coil 2. Going for coil 2. So, this coil 6 is dot. Coil 7 is cross. It is okay. Going for coil 12 is dot. Coil 13 is cross. So, now I want to change this coil 12 and coil component 13 direction of the current. So, either go for right click and go for the reverse coil direction, or just simply click, go for a double click, right? Either go for right click and reverse direction, or just simply go for a double click option, so that the direction of current will be reversed, right? Now again, go for the number of turns. So the number of turns should be same for every corresponding phases, right? Now again, for coil 1, I am giving number of turns for coil 1. So this is coil 1. So the component 5. So the component 5 is dot and the component 4 is cross. So now I want to change this direction. So just double click the component 4 and component 5, so that the machine is now available in the form of Fleming's left hand rule to give excitation, right? Now I want to assign the boundary condition. I want to assign a boundary condition. So that what I am going to do, I just give the circle here, select the circle option at the top of the toolbar. Again giving the toolbar as X, Y. Again giving the initialization as the center point, right? So the circle starts with the origin. Now again I want to draw a circle which is big in diameter, which is larger in diameter as the outer. So the outer diameter is 50. I just going to give the radius as 60, right? So this is the boundary. So the boundary should be found in the form of R. The boundary should be made in the form of R. So assigning a material as R, it is a boundary, and this one is the R. Right? Again, the stack length is remains same. And now the important thing here is, I want to enable this ignore whole option, because I just selected the line only for the outer region, but the inside there is R is available, right? So that also I want to ensure, so that I just enabling the ignore whole option, right? Now I want to first excite which is unaligned condition, the pole which is in unaligned condition. So the coil 2 is in unaligned condition. So I just excite, again rename this one and give the ampere as 6, right? I just give the ampere as 6, right? Now I want to mesh this option. If I want to mesh, so what is this measure? That is finite element analysis, that is FEA. View, just go to the view option and then give initial 2D mesh, right? See here, we can able to see the triangle, right? We can able to see a triangle, and this triangle is in bigger in size. So now what I want to do, I just want to minimize the size of the triangle, that is very finite analysis I want to need. So what I want to do is, just go to the properties of the file, and then go to the mesh and select the maximum element size as 1 and enable as 1 and apply it. And now, so this is the model, right? So this is the measured model for the FEA packages, right? So if you want to get the accurate result, we have to go for this type of minute value of triangle, right? If you zoom and see, we can be able to see the triangle in shape, right? Right? So all these are triangle, right? Now I just go to solve this option, static 2D. I just going for solving, it is solving now. It will take some time, right? Just 1 minute or 2 minutes for one problem, right? So problem means it is the rotation angle. Problem means here the rotation angle, right? Still now I didn't mention any rotation angle. I just given only the initial position of the rotor. With the initial position of the rotor, I just excite the machine, and I found out that the rotor is having a torque of 1.9 Newton meter. Right? During for unaligned condition, the rotor torque is of 1.9 Newton meter. Now, if I want to make the machine to rotate, just go to the magnet, that is properties of the file, and go to the parameters, and then go to the rotation, just angle here. At the last, give the angle and mention that the angle here A should be in small letter. The A should be in small letter, right? And give the angle as 0, 1, 2, 3, up to whatever you want. I just give for a time constraint. I just giving to 0 to 4. I just giving from 0 to 4 for the time constraints. Now, just go to the option and select the rotor. So after selecting the rotor, you just go to the properties of the rotor, that is parameters, and then we can be able to see the rotation angle option which is available here. So in this case, you just give percentage angle, ANGLE, right? See, if this angle A is small, and there also should be small, otherwise error will be appearing. Degree, DEG, right? Okay. Now again, I just going to solve this one. Just for time constraint, I just giving only 4 problems. So problem means it is number of rotation angle, right? How many number of rotation angle the rotor is rotating. So that is the problem here. It will take some 2 minutes, right? It will going to take some 2 minutes now. So now I excite the phase A, right? So similarly, we can go for phase B and phase C, right? The procedure remains same here, right? For phase A, what is the procedure? Again, the procedure remains for phase B, and phase C also is same, right? So still 3 problem is left. Now 2 problem is left. So still only one problem is left, that is only one rotation angle. So in the meanwhile, now we are seen up to how to create the FEA model and how to get a machine model for the FEA, right? So now we are going to see how to get the flux path as well as the flux density value for the unaligned condition as well as the aligned condition, right? Now the machine is fully run. No problem, that is 4 rotation angle, and we can able to see the torque for each rotation angle, right? So this is the torque for each rotation angle, and then we can able to see the energy, what is the value of stored energy and what is the value of co-energy, right? So depend upon the rotation angle, we can able to see the value for co-energy as well as stored energy. Again, we can able to see the value of x direction force as well as the y direction force, and these two forces are the essential for the vibration in the machine as well as the flux linkage. The flux linkage is available. Now we can able to see only flux linkage for one phase. Suppose if you want to see the flux linkage for the remaining all 3 at a time, just select everything. On the top right side corner, there is option as overlap curves. So enable that one and then go for the graph selection. We can able to see 3 graph at a time, right? Not only for flux linkage, for any graph we can able to see. Similarly, ohmic loss. Ohmic loss is 10.9. That is depend upon the current input as well as the number of turns, and iron loss. And these two are the important parameter for the thermal analysis, right? And the time current what I given is 6. Again, if you want to check for the entire 3, we can able to check like this, right? Apart from this, we can able to see our flux function, that is flux path. What is the flux path here? See, we can able to see our flux path, and this is the flux path for the corresponding phases. Again, if you want to see the flux path with the flux density, we can able to see the flux path with the flux density with a value as 2.2 Tesla. The flux density value also is indicating. Again, the value for flux density distribution. Flux density distribution. So this is the value for flux density distribution, right? The value remains same, and we can able to see the difference in the diagram, how the flux is distributed. Again, if you want to see the direction of flux, that also we can able to see. So select the arrow option and go to the B and give, see, just zoom this one, we can able to see the direction, right? So if you want to see exactly, just go to the arrow plot, just give right click, and we can able to see an option as here, lower bound, right? Or give the as manual here and give 3 mm so that the arrow diagram will be bigger in size. And then again go to the properties, again go to the value of lower boundary and give it as 0.5. So this is the value for the flux, how the flux is traveling, right? 0.5 can be replaced by 0.2. This is the complete flux direction of flux. It is not the flux path, it is direction of flux. So we can able to see flux direction, flux path, everything with this packages, right? Similarly, we are having more number of materials available here. We are having more number of materials, right? So whatever material we want, we can able to place this. I just right click and go for the solid model. We can able to obtain this one, right? We can able to obtain this model, right? Just save this one. I just saving as phase A. So now, what I want to do here is, suppose if you want to go for a transient analysis, just go to the circuit window, and then just drag all those things. That is coil, number of phases, right? And then I want to get the circuit here. I just go for a current source for simplicity purpose. Again, I just go to the switches. Here, if you see, position control switch is not enabled. So what I am going to do, just go to the rotor, size the rotor, and then go to the model, and then go for the option as make motion component, and then it is available. See here, motion 1 is available. So now again go to the circuit here, then go back to the position. So now the position control switch is enabled, and then give the position control switch. Right? So now just go to the tools, sorry, circuits. There is a connection wire is available. Right? I just drawing the circuit here. It is a equivalent circuit only. Equivalent circuit of a converter circuit. So we are drawn here. And go into the waveform, just give piecewise linear and give 0 or 6, sorry 0. And here give the value as 6 because we are giving 6 ampere. And then give the value for 0.001, that is 0.1 milliseconds. Again go for the 10 milliseconds, that also 6. And go for the 6 as 100 milliseconds. Right? So that we are getting a graph like this. So the graph also will be available at the side. Right? Now go into the values, the on-off. The on-off value has to be given upon the step angle of a machine, right? Step angle of a machine. So the step angle formula is 360 divided by Q into NR. 360 rotation angle, Q is the number of phases and NR is the number of rotor poles, right? So we are having 8 rotor poles, 3 phases. So 8 3s are 24, right? We are getting 24, right? So 360 divided by 24. We are getting 360 divided by 24. So 15 degree we are getting as the step angle. So just give here as 0. Again next one is 15. Again remove this one. Give apply. Again go here. Again here on time is 15 and off time is 30. Again remove this periodic and give here. Again 30 on time and off time is 45 and remove this periodic. So periodic means continuity. Periodic means here is continuity, right? Again go to here as 45, right? Again give periodic. So it will be in the form of continue. Up to any value of time we can able to rotate the machine, right? 45. So if we start from 45, it should end at 60. So again here starting time is 60, right? So if starting time is 60 and here it should be start at 75. I just give it as 75 and then give periodic. So it is continuously available. The turn on and turn off of switch will be continuously available. Now after that what I want to do, I just go to the solve option and give the transient option as start time. Again I give the stop time as 2 milliseconds. Again step time as 0.1. So the step time plays a vital role, right? So if we give a minimum value of step time, we can able to get a higher value of accuracy, right? So I just giving as 0.1. If you go much lesser, it will be much better values, right? So I just give apply, right? And then I just again save this file before going to run this one because it's a transient one. I just save as a transient file and then just go into the solve option. So we can able to see transient 2D with motion. Just I am solving. So we can able to see the problem left is 4. So what I want to do here is, I just give a rotation angle for the rotor, right? So that I want to make it to 0, right? Just go to the properties. So then go to the parameters and give this value as 0, right? And then now go to the solve transient 2D with motion, right? So now the machine is going on and now it is going to run for 2 milliseconds, right? So we can able to run for any time of milliseconds. Just for time constraint I'm just running for 2 milliseconds, right? So in the meantime, right, I just open this file. So now if we go for our slides, we can able to see our flux path with flux density as well as the distribution of flux, right? As well as the distribution of flux. With the torque characteristics for phase A, phase B and phase C. Now we have to consider about our vibration analysis, right? We have to go for our vibration analysis. So we want to be prepared for a vibration analysis with our FEA model. So how to do this, right? So I just take this file, again rename this file, that is save it as another file as vibration file, right? I just save this file as a vibration file. And then the only thing I need here is stator. Only thing I need here is stator as well as the coils, right? The rotor I don't want, I just delete this one. As well as the coils I don't want, I just delete it, right? The coil I deleted, as well as the boundary also I don't want, I just delete in the boundary. So these lines I don't want, I just delete it. So now what I am doing is I just assigning the FEA model according for our vibration analysis, right? So I deleted the lines which are not needed for us for the vibration analysis, right? So now what I am going to do here, so we are having a stack length here. right? The stack length has 60 degree, right? 60 mm, right? So that is the shaft. That is the shaft. So I want to draw the shaft here. So again, just assign the model here. I just assign the model here, and then go to the make a component in line, right? So, and the shaft should be of non-magnetic material, right? Here it is a non-magnetic material, and the stack length is 60 degree. So I just give the shaft stack length as double the time, right? So double the time as 60. So 60 into 2, it is 120 mm. Right? I just give it as 120 mm here. And now, if I want to see in this direction, the shaft is coming at the only one side, right? But actually what I want to do, I want to get the shaft at the two sides of the stator. I want to get the shaft at the two sides of the stator. So that what I want to do, I just want to shift the shaft to the inside of the stator, right? So I just selected this one. I just go to the model here, and then there is the option as shift component. Just go to the Z and then give it as 30, right? Go to the model, shift to the component. Yes, 30 here. Sorry. And it should be as 30 here. In the Z direction, I just apply this one. If you see, it is moving in the forward side. It is moving in the forward side. But what I want to do, I want to enter into the shaft. So I just give a negative symbol. It is, the shaft is at this side. Now again giving another one. So now we can able to see the shaft at the two ends of the stator. We can able to see the shaft at the two ends of the stator, right? So now we have to apply the boundary condition at these two sides, right? So accordingly I want to save this file. So just go to the file and export this model in the form of IGES. I just exporting the file in the form of IGES. That is a vibration file. I just save this one, right? So I just saved this one. The file is saving. Now what I want to do, just open I want to do this IGES into IGS. I want to convert this file which is in the form of IGES into IGS. So what I am doing, I just opening the another package. This is Pro E for just conversion of the file, for the conversion of the file. So just go to the file here. We are having a open option. So I give the open option here. 1 minute. So again I just going to open this one. So in the meantime we are checking these magnet packages. It is running up to only 0.4. It is running only up to 0.4 milliseconds, right? So this is the boundary condition where we have to apply in the shaft, right? Suppose if it is a inner rotor machine, what we want to do here is, if it is inner rotor machine, right, I just want to go for inner rotor machine. I just taking inner rotor machine. Now I'm just going to open inner rotor machine, right? Right. Just open our Ansys packages and go to the import option and select IGES. Right. After selecting, I just give OK and go to the browse option and open the IGES file where you are saved. Right. Just open the IGES file where you are saved and then just go to our so I just taking the inner rotor machine, right? So this is the model for the inner rotor machine for the vibration analysis, right? So now the vibration analysis for this electrical machine, it has to be done in two formats. One is in the form of modal analysis, another one is in the form of harmonic analysis, right? So what is this modal analysis, right? So modal analysis means we are just going to give the natural frequency. We are going to predict the natural frequency of the machine for the first 5 modes. We are going to predict the natural frequency. So here the frequency is 846 and for mode 2 it is 1923 and mode 3 it is 2023 and mode 4 it is 3037 and mode 5 is 3387, right? So this is the natural frequency of a machine, right? So if you go with the inner rotor machine, the procedure here is just go to the preference and give the structural here and give OK and give preprocessor, go to the element type and give add. So add a material. Since it is 2D, just give a quadrant 8 node 183. If it is a 3D model, just give brick option. Just go for the brick option. Since it is 2D, just give quadration option. And then close here. Then go to the material properties and go to the material models. So here material model is the density of a machine. The density of a machine. So machine means it is a material of a machine, right? So here, again go back to our motor model. So material means here M19 is available. So M19 means what is the density? Just go to the properties and we can able to see the mass density. The mass density is 7600. So just go back here and give our mass density as 7600. Right? And then here Young's modulus, right? Here it is 2 e power 11 and Poinson's ratio is 0.3. Right? So after giving all these things, so these are the basic things for the vibration analysis. Again, we are having the back iron, that is the stator part of the material as well as the coil, right? So we are having two material. So go to the material and just go to the edit option, make a copy and give OK. So the material 2 is available. So the material 2 is nothing but the coil. So what is the density of the coil? Just go to the magnet package and then go to the right click and go to the properties and we can able to see the density here is 8954 and then go back to our Ansys packages and here it is 8954, right? And then close this toolbox and then go back to our meshing here and go to our mesh attributes. So mesh attributes means we are assigned two materials, right? So which is 2, right? So I just pick the areas. So this one is coil, right? This one is the coil. So coil means what I want to do? I want to select the number 2. I want to select number 2. So again, next one is I want to select this back ion. So if you want to deselect, just right click. There will be a change in the direction of the arrow mark. So I just deselecting this one and just go to the apply and give the answer as 1, right? So now I had assigned the material. Now what I want to do, I want to mesh, right? So we should not mesh as it is, right? Just go to the smart size and here the fine size, mesh size is 6 and reduce the mesh size to 1, right? Again give the mesh option, right? So again just select the option as pick all and now we can able to see the file is meshing now, the object is meshing. So the meshing is going on. So now the mesh is ready, right? So now next what we have to do here is, I just want to give the coupling, right? So coupling means the coil and the poles of the stator, right? So because when vibration is going on, the displacement will not be continuously available, right? We can't able to find the attachment between copper as well as the steel. So in that case, I want to couple this one. I select the box option here for my convenience and then coupling this one. And couple should be done in R direction, not only in X and Y, and set the reference number as 10 and the reference number should be different for all coupling, right? Again go to the box option, couple these two material and this will not be available in U tips and all and give 20 and go to the box option, again couple the different material. So wherever there is a difference in material, we have to couple for the vibration analysis, right? We have to couple for the vibration analysis. Again, suppose if it is the same material, there is no need of coupling option, right? If the material is same, there is no need of coupling option. Just we can be able to go for the analysis. So I want to couple all the poles with the coppers. So give 70. So each and every reference number should be different. Suppose if any reference number is same, the coupling will be attached to each other, right? So that will not give our result exactly. So while coupling, we should be careful such that the reference number should not be same and the coupling should be properly available. Now I want to move the option at the top. So I just select this option which is found at the right side bottom. So I just selecting this one. So giving apply here. Again Again, I want to select the remaining 2. It's 140. And this is 160. Right. So now the machine model is ready for our analysis. Right. So just give fit view so that we can able to view the entire model. Again, then go back to our loads and give our analysis type. Go to new option. So now we are going to do our model analysis, right? So after doing the model analysis only, we can able to predict our natural frequency of the material, right? So what is the need for predicting the natural frequency means? So if the vibration frequency and natural frequency coincide each other, the machine while running, it may lead to the acoustic noises. In order to remove the or in order to eliminate the acoustic noises, we have to go for the modal as well as the harmonic analysis, right? Now go to the loads, go to the apply loads and go for the structural option and just go to the displacement and now select the lines here. So select the bottom 2 lines. So the displacement is 0. The motor should not be displaced at the bottom. So this is the boundary condition what it is applied to the machine here, right? And then now go to the solution and now go for the solve option and just do current LS and give yes, and it is running now, right? It is running now, and meanwhile we are just going to our transition. So still transition is running for 1.5 milliseconds, still 0.5 is remaining. And the solution is done for our vibration analysis. That is for modal analysis, right? The solution is done for modal analysis. Right. So now what I am going to do, just I want to go to the general post-processing process. So just see the result. So this is the summary of a result. What is the natural frequency? So the natural frequency for the different modes, that is 5 modes. So mode here means in MATLAB you will see natural vibration. What is that? First 5 modes: first order harmonics, second order harmonics, third order and fourth order harmonics. Similarly in machine, the vibration can be termed as the mode 1, mode 2, mode 3 and mode 4 and mode 5, right? So accordingly, if you want to see the mode 1 displacement, go to the read result, select the first set and go to the plot result, go to the contour plot and go to the nodal solution and then select the dy of solution and go to the displacement vector sum. We are able to see our solution here, right? So this is the displacement value. So at the top of the left side top corner, we can able to see the frequency value. It is 1392. Just go to our, if you go to the plot control and go to the style and go to the colors and just go to the reverse video, right? So that we can able to copy this file and just we can put in our publications, right? So for putting a publication, just go to the plots, plot control and go for the capture image, right? And we can able to save this image also, right? We can able to save this image also, right? And we can able to easily put in our paper, right? Now, for the second mode, read result, next set, go to the plot result, contour plot, again deformed vector sum, right? And this is the second mode shape. See, for different modes, the shape of the machine is now deviating. So it is 0.27 the maximum red color indicates is the maximum displacement, and similarly, depend upon the color variation, the displacement value is indicated at the bottom side, and which is having a unit of micrometer, right? The unit here for the vibration is micrometer, right? And then for mode 3, nest reset, plot control. Suppose if you want to select the initial position, just select this option, deformed shape with undeformed edges, select now. We can able to see the original position as well as the deformed position, right? So how it is deformed, that also can be visible, right? So this dotted line is the original position, dotted black color is the original position, and the colored one, the various color is there, and that is the deformed position. So now we can able to see how the machine is now deformed from one position to the another position. So this is mode 3, and coming to the mode 4, and just save the result file, so the further analysis it will be useful for us, right? I just drag it down, and for the next set, plot control, nodal solutions, and then go to our, okay, now we can able to see our mode 4, which is having a natural frequency of 7327. So when modes is increasing, the frequency of the machine also is increasing. When frequency of machine is increasing, the displacement also may be increased, right? So that depends upon the shape of the machine. So for the mode 5, which is the last mode, so mode 5 it is 7327, right? So now what do I want to do? I want to go for the, go to the analysis type, and just go to the new, just go to the harmonic analysis. So define loads, apply the load here, and go to the structure option, go to the force, and go to the nodes, select the nodes, and go to the plot, and go for the node option, so that the nodes is available, and select the values. So if you want to do this one, we want to need the value of force here. So to identify the value of force, we want to go for the magnet package and check the value of force here, right? So x direction force and y direction force for the stator, right? So this is the unbalanced magnetic force, right, which may form the vibration in the machine, right? So just select this one, right, and then giving apply x direction. So x means the motor is now going to be rotated in the counterclockwise direction. So for that I just give the value as, what's the value we have seen here? We have seen the value here as x direction 3.6, and it is 1.2. I just giving here, go to the notes, the x direction is 3.6, but it is in the reverse direction. The machine is now rotating in the anti-clockwise direction, and give apply, right? And then now give a in the y direction for the same nodes, and give OK. In the y direction is 1.2. It is 1.2. 1.2 means it should be come in the downwards direction. It should be come in the downward direction. So give in the minus aspect, so we can able to get the direction of y in the downwards, right? Now select the opposite two poles, that is one phase. I just selected for the one phase and give apply. Now the y direction should be in upwards, so I just give in the positive. Now again I select the nodes here, right? Now after selecting it, just change the direction as x direction and give it as 3.2, and this 3.2 should be in forward direction, right? So now we can able to see the rotation of the machine. So the rotation of the machine, rotor is in now counterclockwise direction, right, which is rotating in counterclockwise direction. Now just go to the define step loads, time bar frequency bar substep, and for the time constant just giving 1000, right, just give 2000 here, and substrate value is 200. and solve the machine, right? So the machine is now running. So in the meantime, we will check our transient file. So if you go for our transient file, we can able to see our motion value here. We can able to see our motion value here. So the torque. So if you go to the torque of the rotor, we can able to see the torque of the rotor as it is the starting time. It is the starting time. If you want to get the saturation time, we have to run the motor for the long duration of the time, right? Now again, the things what are needed here is again the feed. What is the direction of flux? If you want to animate this one, we can able to animate it. Just give the flux direction and select the flux here, and just give animate here. We can able to see how the rotor is rotating here also, right? So if you see at the left side bottom, we can able to see the animation is preparing. That is 8 out of 21, right? The animation is preparing now. And now we can able to see generation of animation for each microseconds, milliseconds. The animation generating here. Meanwhile, the Ansys file also is running, right? Frame 12, 13 is over. Still 9 is there. So the machine is running now. Now if you go for our presentation, right? So we can able to see a natural frequency of as this one for the first 5 modes. If you go for our harmonic analysis after applying load, we can able to see the peaks here. We can able to see the peaks here such that for the x direction the peak value here is nearly to 800 plus. If you go to analysis, the 800 plus is available at mode 1 and the second peak available to 2000 plus. So here 2000 plus is only 1. So mode 1 and mode 3. Again going back to our y direction, 800 plus is mode 1 and it is 8800 plus. So 8800 plus means it is not. From the harmonic analysis we can able to see that the machine should not be operated at mode 1 and mode 3. So this is the prediction what we have obtained from the model as well as the harmonic analysis. So from this we have to come to a conclusion that the machine should not be operated at mode 1 and mode 3. Right? Then only we can able to eliminate the acoustic noise in the machine, right? So coming to the thermal. So in thermal analysis, so this is the FA model, and here we are condition, and now we are able to see how the heat is distributed inside the machine, right? So these are the possible analysis what we can able to do in our Ansys packages, right? But the thing here is it will take some time to run the machine, right? But it is a user friendly. If you go for another packages, SolidWorks under, it will take much more time and it is complicated one, right? And EMS packages and CATIA, and that also will take much more time, whereas the Ansys will give the accurate result, right? Meantime, you go for transient packages, and now the animation of the file is now ready, right? So this is the animation file for the transient now. Since it is 2 milliseconds, we can able to see the rotation of the file, right? So with this, so from this we can able to say that I just give an intro about the Ansys packages as well as the magnet packages, right? So I will just upload I give the link of the recorded section of this today, as well as the detailed procedure of doing the electromagnetic analysis for the static as well as the transient in the electromagnetic analysis for the magnet packages as